Hey there, welcome back to Farmcraft. I'm John, this is Large Marge, and we're getting back to work on this track adjuster job. By the end of this video, I plan to have this job all done, and we're going to move on to something else. Now you can see I've already got the other side apart. I do have the replacement seal, but before I go putting that back together, I'm going to go ahead and take this side apart. I want to get a look at the spring. I want to see if it's also broken, and I want to do a little testing. The way these springs work and how that tension rod, how it has an effect on the machine in the future is kind of hard for me at least to visualize and really understand. Reading your comments are kind of all over the map. Some people think it's going to do one thing, some people think it's going to do another, but I think I've got my head wrapped around it, and we're going to go through all that in this video. I'm also going to do some checking to verify that I'm thinking about it correctly. So the first step is going to be to bring the master pin around to this side, get some track plates off, and get ready to use our new pin press and split this track as well. So let's get to it. I'm going to put this camera on this tensioner and spring, and I want to see what happens to it when I pick the track up off the ground. I think the spring is going to move. Now this track is properly tensioned right now. You can see some grease squeezed out, but it hasn't really moved since I tensioned it. I've also marked there on the side wall where it is so that when I take it apart, I'm going to be able to see how compressed the spring is. But see, the thing is right now, the track is on the ground. When I pick it up, the weight of all those plates and the chain is going to be putting pressure on the idler and trying to push it that way. So I think the spring is going to move. We're going to find out. It definitely compressed a little bit, not a lot, but that does tell me something. And I've rotated it around so the master pin is right here, and the master pin, it's definitely going out the other way. It's not even all the way in. We come around the other side, you can see it's... All right, so I cleaned it off and I scratched a crow's foot right there into the steel. I used a square to mark where that crow's foot is. So that is where it is when the track is up off the ground and tensioned to 16 inches between the plate and the frame. So now I'm going to let the tension out of the track adjuster, and we'll see where we are then. Release the shmoo, or not. That's surprising. Huh. Not a speck of grease coming out of that thing. One other thing I want to address real quick, I always appreciate people's comments. Many people seem to think that my idler was too far out. I don't think it is. I think it's where it's supposed to be, but I can tell you the spec for this machine, full length is supposed to be 15 feet 4 inches. They don't say exactly what you measure to. I figure it's got to be the track plates because the grouser heights are going to vary. But anyway, let's see what mine is. 15 feet 4 3/4. I'd say that's within spec. People were thinking maybe I needed to take a track link out to shorten the whole thing. I don't think that's the case. The undercarriage on this actually does not have a lot of wear on it. These were clearly replaced. In fact, I'm sure of it because all the track bolts are imperial. They're 3/4 inch bolts. They're not metric. One of the few things on this machine that's not. So I'm going to go ahead and lower this thing down. I can't get the grease to come out of the track adjuster for some reason. Obviously I need to rebuild the track adjuster. That's what we're doing anyway. Note that the spring expands when it's lowered to the ground. This is important later. Oh yeah, it definitely moved. I'd say 3/4 of an inch or something. So the master pin is right there. So these two plates need to come off. So this first bolt was already loose and spinning. I just had to wedge a crowbar in there to get the nut to stop from spinning, and it came right off. Good start, but all the other ones were stuck tight. Well, that took some doing. I killed the battery in the Milwaukee, so I had to finish out with the DeWalt, and I ran out of oxygen in my oxy-torch setup. But I did get 8 bolts out. You can see that this has been bent, so I'm just going to open that up a little bit so I have room to put a pin in there to push. So that's going to be my push pin. So let's try out this pin press I built in the last video. Well, the height is good. These pads get it to the center line of the pin, but that is hitting. I don't want to take another track pad off. So what I'm failing to communicate here is that it's centered vertically, but it is not centered left to right. It needs to move in this direction for the holes to line up with the master pin. But it's hitting this track pad. I kind of wanted to leave this round in case I wanted to drill more holes. I could rotate it to a different configuration, but the easy thing to do here is just put a support thing behind it. And I think that's what I'm going to do. I just turned this down on the lathe to use as something to push through, but that does complicate things a little bit because now I've got to juggle all this. Yeah, that's so nice to be able to just adjust it to the length that fits compared to welding that thing up. That made it so difficult. And many people suggested that I permanently attach the jack to the plate, but that would make the whole thing very heavy, very unwieldy to put together. All right, I am all set up here. I've got my push pin in. I've got the pipe there to push through. This would have been much easier with 2 people again, because this stuff's pretty heavy, managing the jack. But anyway, doing it alone, a big clamp that you can just clamp down those 2 rods on the top was definitely a big help. Let's get ready to push. Sounds like I'm an obstetrician or something. Something's moving. Ooh, that's a lot of force. And I don't have any oxygen in my oxyacetylene. Let's try an air hammer this time. No, yeah, not currently. Feels like it might have gotten a little easier. Oh yeah. Oh, man, I really need some heat. Wow. All right, I forgot something. I got excited about setting up my pin press, and I wanted to set it up, and then once I knew how it was going to lay, I wanted to put a come along on this and take the tension as much as I could off of this track, because this track is still tensioned, and here I'm pushing the pin out. That ain't helping. I might just keep on pushing since I'm making progress. Once I get this entire thing pushed in, then I can take the pin press off and look at come alonging the tracks together, and then hopefully just do the rest with a sledge. It's doing it. That's a testament to the strength of this pin press. To be able to push this pin out while the track is still tensioned because the operator's an idiot. Yeah, I think that's as far as I can go. That is the pin, and obviously it would have been nice if it had been centered. I could have pushed it, kept pushing, but I might have to do something about these plates. So what's my assessment of the new pin press? I think it did a great job, considering that I was pushing a pin out that was still under tension, and it had no problem doing it. So there you can see the pin, and obviously they mushroomed it, pounding it in, and it's cockeyed because that track's under tension. So this is pulling it that way, and this is pulling it that way. Still got it out. 50 tons is a lot of force. Losing daylight here, but I've got a chain binder going in a loop here, so that should take the tension off of this really well. All right, there's that. Is it moving? Not much. The geese are applauding. It's a lot of them. Tired of playing. We're using the big boy. Good hit. So I don't know if you guys can still see anything or not. The pin is out. That was my goal before dark. I actually didn't start this until afternoon, and it is 5 right now, and I lost a significant amount of time drilling out that sleeve to pound through. If it wasn't for that, I would have done this in a few hours, which in my book, doing it alone, removing a master pin on a track this big, I'll take it. The last one took several days. Anyway, it's getting dark. We'll see you tomorrow. There you can see it. The piston that wouldn't let the grease go. We're going to talk about that spring in a minute. Let me get this thing ripped apart and let's see the state of that spring. I suspect the tensioner rod is broken in this one too. So now the spring is under no tension whatsoever. And I'm marking this location too. And as suspected, I suppose it's just fatigue from years and years of holding back this spring pressure. And there's 1.5 inches between totally uncompressed and tensioned. So that's really good for me to know. So using the mini excavator, this spring should just pull right out. Should just pull right out. Should just... What broke? That ain't no good. All right, it's under tension. It's picking up the far side of the excavator. Now let's see if an air hammer can do anything. There's dirt all packed around this spring like there was on the other side, and I'm thinking that vibrating it might allow the dirt to loosen up and let the spring come out. But Large Marge has other ideas today. She feels like fighting. Here I'm trying a digging bar to shift the spring back and forth while it's under tension. Every step of the way. Yep, it's time to go full caveman. So I think I'm going to have to try to dig dirt out so that I can move the spring. That's going to be fun.
Ten years later.
So kind of the same story on this one. I've just got it placed together. The end of it is about right there, and this one, you can see that rod down in there where it's broken, is about right there. When I measure this precisely, it's just over 4 inches that it was compressed. And this thing totally uncompressed measures 40.5. Quite close to the crow's foot that I made for when it was uncompressed. When it's compressed, I'm closer, I'm just shy of that 39 mark. I don't know if you guys can see that crow's foot there. So the difference comes out to about 1.5 inches or 37 millimeters. That was about 1.5 inches difference between uncompressed and properly tensioned. So that means this would be 1.5 inches shorter when it was properly tensioned. So that corresponds to this guy sticking out 2 inches. So this whole thing is 9 inches. So I wouldn't want that piston to stick out too far, but certainly it could stick out a couple more inches and that would be just fine. So now we need to go talk about this spring and really understand what it's for and how it's going to affect the behavior of these tracks. Let's look at a model to help understand this. This represents the frame. This is the back of that tunnel that I just swept out, and it's what the spring is sitting up against. So consider this an immovable object. This is the track tensioner cylinder. You can make it longer or shorter, and that's how you adjust your tension. So it's sitting right there, and then here's the idler wheel. And then obviously the tracks are going around that. So when you make this longer, it pushes out against the spring and puts tension on the tracks. My initial thought was, I mean, the tracks are immovable too once you get them extended to whatever length they are. It's a chain. It's not going to get longer. It's going to rigidly push back. The spring's sitting there, and say it's under no tension, it's at this length, and I start pumping grease into the cylinder. What's going to happen as this gets longer and longer, now this isn't actually a cylinder, so I can't really show you, so I have to do it like this. The tracks are going to push back against it. It's pushing, 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 and the spring is pushing back harder and harder the more you compress it. But it's going to push until I get the right measurement between the frame and the track pads and say, okay, there, that's good tension. And I thought, well, all right, well, now it's tensioned. The purpose of this spring is to give some give to the system. If we take the spring out and we tension the track so that it's under proper tension, if you are now running along and you hit a rock, hit a stump, or you do something that's going to increase the pressure on this track adjuster, you're going to get a big pressure spike because there's nothing to give. You've got pins, you've got the chain, you've got the frame, and a hydraulic cylinder here. And what's going to happen is these seals are going to get blown out, and then you're going to have no tension and the track's going to come off, and you're going to have a very unhappy operator. So that's why they put this spring in here. Basically, it just gives you a little bit of play in the system without losing all tension on the track. So back to my initial thought, I was thinking, okay, well, once I get it tensioned, assuming everything stays in line, it's not really going to matter because any additional pressure on the system, the spring will do what it's supposed to do, and then it will just come back to this amount of spring tension.
So what's the purpose of this rod in the first place?
My thought actually was that rod was for two reasons: to make them an assembly so that they hold together, and it would make this easier to assemble, and it would also, springs have a tendency when you're compressing them to want to spring out to the side like that. And I thought, well, the rod would be in there to keep it in line. I think on some springs that's absolutely true. I think on this spring where the rod making the spring is 2 1/4 inches and it's in a tunnel, it's just not going to do that. I don't think that's not what the rod is there for.
I think I know what it's there for, but it requires a little explanation.
So right there is 0 pressure on that spring. And I'm just going to do one, we'll say tons. I have no idea how much pressure is actually on this thing. It is on the order of tons, I think, but who knows? Well, let's just do this. Let's say there's 1 ton, and there's 2 tons, and let's say 3 tons is what you need to properly tension your track. So that's where it would ride if I leave that bar out, and the whole thing is going to be constantly under the tension of 3 tons, unless you hit something, and then, you know, it might increase the pressure, and you might go up above 3, but you'll never get below 3. But let's say the spring was pre-tensioned to the 5. It's pre-tensioned here by the rod, so even if I take the pressure off of the track adjuster, the spring is going to stay at that length. So what that means is the end of the spring has now become essentially an immovable object again to the track adjuster. It's going to just push the idler out, and the tracks will get to the proper tension, and then you stop. The spring has not moved at all. Now I lower that track back down to the ground, and what you're going to get actually is release of pressure on this system, because the spring is not doing any additional pushing. It hasn't moved because it is pre-tensioned farther than you need to tension the track. So think of the spring as an immovable object except in the most extreme circumstances. Then what you have is your track adjuster, which pushes against the spring, but then when you lower it down, it actually relieves some of the pressure. You get a tiny bit of, I don't want to say slack, the track isn't slack, but it's not quite as tight. And under normal circumstances, you're going in a straight line, you're on flat ground, you're not using the machine, it's just sitting there idle. There's not going to be pressure on the track. It's just sitting there. So if I leave this rod out, this spring will constantly be pushing on the tracks. Every time it rotates, whether you're going straight, flat ground, it's going to always have pressure on those pins. With the pre-tension in place and the proper tension, there's actually going to be less wear and tear on the pins of the track chain the entire time you're using it. So actually, the pre-tension rods are going to increase the life of the undercarriage. And once I realized that, you can probably see where this is going, I realized I have to fix this, because the last thing I want to do is wear out all my pins and my tracks and end up having to replace this stuff. Replacing this one rod is going to be a lot easier than that. The other thing to consider here is, because the spring is now shorter, that means when I do take the tension off of the track can become looser. If the spring is allowed to go to its full length, the whole system is longer. So even when I compress the track adjuster as far as it will go, the track is only going to sag so much. When I checked my tension, track adjuster was as short as it would be. I was only 3 inches out of spec. And if I had a pre-tension rod in there, that would allow the idler to come back even further. I would be much looser, and in that case, actually able to take the track off without splitting it. Enough rambling. Long story short, I need to fix these tension rods. Several people pointed out, I didn't realize it when I was first looking at this, how this thing was put together. Now there's that back collar on there. The reason for that is it allows, when the spring compresses, it gives the bolt somewhere to go. So the bolt head can move as the spring moves. So the spring is basically trapped in here. So how did they put this together, and how can I do it safely? Well, I think it's pretty easy, actually. This is nothing but a big bolt. Those threads right there thread into this piece, come all the way through that piece. That's the end of the bolt right there.
They probably assembled this with a huge press and then just screwed the bolt in once it was compressed to the right length. I'm going to do a long bolt. I'm going to use the bolt to compress the spring, and then I'm going to cut the bolt off.
So we're going to have to do some machining, but I think it's worth doing, and I like machining. And we're going to fix these pre-tension bolts here. I went bolt shopping and I was not able to find anything. These are M48 48 millimeter bolts, and it's actually a 1.5 millimeter pitch. This is 2-inch, which would be 51 millimeters, 4140 steel. So this is going to be stronger than these were, and I'm going to drill that out and then put new threads in it to whatever I thread this to. Now you probably noticed I don't have a bolt head on here, and I need one because that's how I'm going to be tightening this thing down. I think just welding it is not a great idea because this thing's going to be under a significant amount of force. The last one broke. I want this thing to be strong. So I've got this piece here that I can use to make a nut. I'm going to thread this end. I'll thread the nut on and then weld it. Should be a good permanent bolt head for me on that end. This end, I have to do a long thread on it. It's going to screw through this plate as I'm tightening it down, and then once I get it compressed to where I want to get it, I will then take a grinder, cut that bolt off, and peen it in place so that it can't unscrew. And I got to do this twice. It's going to be a pretty big job, a lot of machining to do. Let's get to work. So this thing's all rusty and cut off at an angle. So I'm going to take the rust off on the belt grinder and then clean it up on the lathe. Close enough. So making something this long on my lathe is definitely going to be a challenge. So there's a lot of this, and this, and this. Again, I'm pushing my lathe kind of to its limit. I think the minimum length that I want is 35 inches, and 35 inches lands right there. The problem is I need to use the tailstock as a center, and it doesn't leave me any room to do that. I should point out on this lathe, anything that's 1.5 inches or less, you can just run it through the spindle, and that makes things a lot easier. You know, and when they measure the distance that a lathe is able to turn, it doesn't necessarily include the chuck, because maybe you're using a different kind of chuck. You might be using a faceplate or something. The chuck definitely takes up 3 inches of space here. So I'm trying to figure out how I can squeeze every inch out of this lathe. One thing that's always kind of annoyed me about it, so here's my my live center. This is on a bearing here, and You put it in the tailstock like that, and there's a taper in there. And when you back it off, you hit a certain point right there. The shaft of this that I'm turning here is now hitting the end of that tool. And that's useful because it ejects it. So now it knocks it off the spacer. So the shaft in there, I think you can see that shaft in there. So the shaft stays in a fixed position. So right there is where it's touching. So I've just ejected the tool. So you can see the back of the shaft is right there. Now when I crank it out further, the shaft stays put, and now this only reaches to there. So as I'm cranking it back, it goes and goes and goes, and then the shaft hits, and this gets ejected. So that's useful, but look, I'm at like 1 1/8 inches there. There's this much travel of my tailstock that I'm not able to use. Do I shorten the shaft? Would there be any negative to me cutting that shaft off? I don't want to do it and then really regret that I did. I don't know, it seems to me that would allow me to use this all the way to 0. So if I cut the shaft back to that length right there, would that be a negative? Would that be something that I'm going to end up regretting? So another thing in this equation is this is a live center. There's a bearing in here, and that takes up a lot of space. You can use what's called a dead center. Significantly shorter. It's dead because it's just a solid piece. And yeah, see, this one starts hitting, so they're not all hitting exactly the same. So the dead center eliminates this, gets me that much closer. Measuring from the face of the chuck, I'm still like 32.5. I need 35. So how do I get there? So looking at how this tailstock works, obviously it slides on the profile of the ways, but there's this little stud sticking up that the clamp hits. So I can take that stud off of there, and that's how you actually remove the tailstock. You can slide it all the way off if you do that. But this clamp is just attached to this lever here and tightens down on the ways. So I could actually come all the way back to here and still have pretty much full clamping. So I'm still reasonably supported here. That would help. Let's see what that gets me. At the front of that center, I'm still 33.5. A couple things I can do. You can see this dead center is sticking out farther than it needs to. The problem is this is a hardened piece of steel. I don't have a tool post grinder. I also try to avoid doing grinding on the lathe if I can. I could grind that down, but I need to keep it centered. This is the 3-jaw chuck that came with the lathe. This is a piece of 1.5 inches. And you can see it fits right into the bore. Here's a piece of 2-inch, and it most certainly does not. And I'm working with 2-inch here, so that's why I've been measuring from the face of the chuck. I measured the width of this chuck and see that it's 3 inches. And it also came with a 4-jaw chuck. I checked that one. It's also 3 inches, but the 4-jaw fits 2 inches. Well, that's awesome. Rather than measuring from the face of the chuck, I basically can measure this is what I measure off of. I'm going to be able to run the bar all the way to this point before it's going to hit anything. I actually have 36 and almost 1/4 inches to the point of that dead center. Actually, I've been doing some more figuring. I won't bore you with that. It's just deciding how long does the bolt absolutely have to be. It needs to be threaded into the end plate enough that I can start to twist it and be able to compress the spring. So I need to have significant thread engagement with no pressure. 34 inches is going to work. So we're fighting for every inch. That's something I'm familiar with. I phoned a friend, asked him what his lathe did. His tailstock pushes at 0, 900 thousandths. So yeah, I'm going to man up. I'm going to pull that shaft out of there and we're going to cut it off. I don't see what problem it would give me. Worst case scenario, I'll need a new one of these one day for some reason, and I can make it or buy it. I just don't see it happening. I feel like this was just designed wrong, that it's pushing the tools out that early. And the reason I'm doing this right now, even though I did get the length that I need, is center drilling it with the chuck on there is still going to be very difficult. This is going to give me an extra inch that's going to make this a lot easier. So let's do it. There you go, there's the shaft. I just need to cut 900 thou off the end. Hopefully I won't regret this. I just checked it with a file. It's not that hard. So I think I can cut it on the little bandsaw.
Yeah, that came out nice. And I realized as I was doing this, I might lose some of the travel at the other end when I'm all the way out. It might actually disengage from the nut. But this is still better because I'm gaining closer in and it's increasing the length of the lathe. I would rather have it this way if I do lose some of that. So we'll see when we get it back together. So now my chuck ejects at 0. It doesn't reach all the way though, so I'm going to have to give myself a mark to tell me when it's about to disengage. I lose it right there. But it goes right back in, so it's not a big deal. This won't come out because it's got a key on it. What that did though, gave me an extra inch of capacity. I'll take it. I even put the stop back in for the tailstock, 34¼ to the very tip of that center drill. All right, been giving some thought to this. I'm doing a 2-inch 12 TPI thread. Now, the better way to do it would be to do the external threads on the bolt, measure them with thread wires, and get those dead on according to the machinery handbook, and then make a nut to fit it. Unless you have tools, which I don't have, measuring the threads on an internal bore like a nut is difficult to do and not something that I can do. But these threads don't actually have to match the industry standard for 2-inch 12. They just need to fit each other. I'm not going to use these for anything else other than this application. So as long as they fit together, that's fine. So it's much easier to machine external threads if you have a nut to go on and see if it fits. You don't have to take anything off of the lathe. You can test it. What all that boils down to is I'm going to make the nut first. We're just going to get it as close as we can based on the major diameter and minor diameter of the threads. So first thing I'm going to do is drill right all the way through it to 1 inch. And now for the boring part. I'm getting close to my target bore size, so I'm taking smaller cuts here. .915, that's my target. So we got 1.908. Put a little bit of lube in there, and we're going to do one more cut. .915. I'm going to put a little chamfer on that edge, and then we're going to go cut this in half with the chop saw. The basis of all single point threading on a lathe is that you can control the gear ratio between the rotation of the headstock and the rotation of your lead screw. So when they're engaged, you spin one, you're spinning both. And if you then engage the carriage, which you do with this handle, now the carriage is going to move based on the speed of this. So what you're doing with these dials is you're changing a series of gears, and they tell you what dial settings you need to get the right gear ratios to cut different threads. So you can see on this lathe I can cut anywhere from 4 threads per inch to 56 threads per inch. Metric wise, 0.4 and all the way up to 7. You're changing gear ratios with these dials. That's really easy, but there's 2 gears back there that you have to change based on what the chart's telling you here. So I need to be BD 2V, and I need gear A to be 56 tooth and gear B to be 54. So I don't even know, you have to take this cover off to see what the gears are. I don't remember what they are at this point. This needs to be 56. And it is. Hey, that's nice. And 54. Wow. Okay. Lucked out there. Why did I have that on there? I don't remember cutting any. That would be for cutting 6, 12, 24, or 48 TPI. So yeah, typically you undo a cap screw here. You have to loosen this guy because it's going to need to rotate. And then you pull the gear off. You put the new gear on that you want. You have to set the spacing. I usually use a piece of paper. It takes 15 minutes. It's not that hard, but it's just time you don't want to spend when you're just cutting a thread or two. Now, when you're cutting a 2-inch thread and you price out the tap and the die for that, the single point threading and the 15 minutes you're going to spend changing this becomes a whole lot more reasonable. So what did I say? B, D, 2V. 2V. BD2V. So that will now cut 12 threads per inch. So now that we have ours set for 12 threads per inch, that means every time this thing rotates 12 times, that carriage will have moved exactly 1 inch. And it's really just that simple. So I'm using this little high-speed steel cutter. Its ground is 60 degrees as my threading tool. I'm just touching it up on some stones. Quick rundown of what I'm doing here. I'm actually going to cut the thread on the far side. That means that the carriage is going to be going this way as I'm cutting, and there's no risk of crashing. Oftentimes people thread towards the chuck, and if you don't disengage at the right time, you crash the lathe. Because this is a very thick nut, it's 2 inches, I've got a lot of stick out here on my threading tool, and I'd want to keep that minimized. I would need additional stick out to give me room to stop, account for any error there. What I'm going to use to decide when the thread is done is thread depth. So I've got a dial indicator here. It's set up on the tool post. Now I'm going to be advancing with the compound, but the compound's at a 29.5 degree angle. So 4/1000 advancement this way does not equal 4/1000 advancement into the thread. My thread depth, because my minor diameter is 1.915, the major diameter is 2, so the difference there is 85 thousandths. So that's the diameter thread depth, but each side, each actual thread is going to be half of that 85, which is 42.5. So that's what I'm going to do. I'm going to continue to advance this compound until I have done 42.5 on this dial indicator. So here's the motions I'm going to be going through. I will engage a cut with this. And once the cut is done, with the cross slide here, I'm going to pull back and disengage the cutter from the work. And then I'm going to put the lathe back in the position that it needs to be in. It'll be, it'll be here actually. And then I'm going to put this back where it was, back on 0. And now I can advance my compound. So this is deepening my cut. I'm going to engage the lathe again. The lathe is going to go through and do the cut. I will disengage once I see it's completed. I will back out. I will put the lathe back into position. I will back in, go back to the 0 point on the cross slide, dial in another cut. And I will just keep doing that until I have taken 42.5 thousandths on this dial indicator. So how do I disengage and re-engage and end up at the same point on the thread every time? I've got a thread chasing dial here. This spins as the lathe spins. And you use that to decide when to engage so that you hit the thread at the same place every time. It's different for each thread that you cut when you can engage. You can see there for a 12 TPI, you can engage at 1 through 4. That means any of the solid numbers. So I can engage it on any number. I don't want to engage it on the half marks or anywhere else. And that will keep me at the same point on the thread. 8 threads you can engage on any mark. So it can be any number or the half marks. But like 7, it's got to be 1. It's kind of interesting the way these things work out. I'm going to touch off, I'm going to 0 my dial indicator so I know my starting point, and then we'll do a scratch pass. So I'm zeroing the cross slide dial and the dial indicator to measure the thread depth, and we are finally ready to start threading. Except I just hit something, and I shouldn't be hitting anything right here. Well, because this tool actually sticks past the cutting edge, it was hitting the chuck right there. I was using the 3-jaw because it's better at grabbing hex stock, but I'm switching over to the 4-jaw because it has the larger bore and should solve this problem. That's what I wanted to do, set this all up again. It really wasn't that bad, but I'm definitely not going to pass up on the chance to complain about something. Okay, now we're ready for a scratch pass. Here's a 12 TPI gauge, and that looks right on the money. I have to do some lighter cuts, I think. I was kind of worried about that. This high-speed steel is not loving the 4140 and sticking out that far. I have ordered a carbide threading tool. I actually have a carbide threading tool, but it's not big enough to do 12 threads per inch. The thread is too deep. And it'll get here. Till then, I'm going to keep doing this. It is the depth that I wanted. So I think that's it. Looks like a big ass nut. Now that I have a nut, when I do an external thread, I can test fit it with this and know that they're going to go together. So the next thing I need to do is one end of our bolt. Never turned anything this long on this lathe before. I'm going to get this indicated in, and then I'm going to indicate here by the steady rest at the other end. That's within 1/1000th. That works. I'm thinking I'm going to do the same thing on this end, but I'm forgetting something about steady rests here. I've come across this before, and it just takes me a minute to remember it. That doesn't necessarily center it, does it? Can't use this like a 4-jaw chuck because this thing will bend. You know, if I keep pushing those up, the whole thing will bend upward slightly in the thousandths, but then it'll be held in an upward position, and when you rotate it, it'll just bend every time it rotates, and you'll think it's running perfectly true, but in actuality you're high or low or to the side. What you typically do is you get it as close as you can, and then you turn it down, then you're perfectly concentric and you roll on. But I need all of this diameter here. I try marking it with a center finder, but of course, as usual, the marks don't actually intersect, and that means it's going to be not very accurate. So the best thing that I have to use is my tailstock. It is centered, so I am going to measure around it as best I can and then move the wheels up and down to get this perfectly centered. With the exception of a centering chuck that's for the tailstock, this is the best thing I could come up with. If somebody knows a better way to do this, please comment. Well, that was actually easier than I was expecting. It occurred to me as I was fiddling around with this that I can measure this diameter and subtract the two. It comes out to 420 thousandths. Divide that in half. 210 is what I should have all the way around. Well, I have a wheel directly down on the top, so I adjusted that to get it exactly 210, and then I just have to do side to side, and I can play with the two other adjustments until I got those both 210. And it's dead on to the thousandth that I can see. Is there room for a live center here? I believe there is. So I'm curious how close I got. Worth knowing if that was a good technique or not. So I am going to back off on these. 5 thousandths. I can live with that. And did you guys see my screw up yet? Let me fix it. Yeah, you can't crank your carriage past the steady rest. You got to put the carriage on the side you're going to need it on before you put the steady rest on. Dummy. So now I need to make a place for my thread to exit. This button insert wasn't so big. It's nice to have a radius so that it leaves a rounded edge and doesn't make such a stress point. This tough 4140 steel against this large cutting edge makes for a lot of chatter. So I'm just going to use the threading tool. Maybe I'll cut a radius into it with a file later. So I need to touch off, 0, and do a scratch pass. So let's go. I am zeroed. I'm not deep enough to get a full cut because of the 5/1000ths, but that's okay. I started out using cutting oil, but it was actually obscuring my view on when to disengage it, so I changed over to anchor lube, which doesn't smoke nearly as much. Ooh, it's starting. Nice. Just not there yet. Okay. I also filed off the top of the threads because you'll push a burr up and that will prevent your nut from going on. Boy, it's close. So the thread was really close, but it was kind of tight hand threading it on. But I could force it on by hand, and then after that it thread on pretty well. I suspect that's probably just operator error. If I was better at cutting threads, it would have just threaded on. Well, that is awesome. That is the bolt head. It is actually going to get welded up here. It actually feels really good now. There's very little play in it. I think the reality is I just didn't thread the nut quite as deep as I should have, but we're talking about like, 10,000ths deeper. Yeah, I think this is going to work great. So I'm going to use one of my chainsaw files. I don't feel like I got a full depth thread on the nut, and I definitely got full depth, maybe even a little past, on the bolt, on the shank. What I want to do is the next nut that I thread, I'm going to thread it a little bit deeper. This one I did my thread depth at like 43,000ths. I'm going to go to 50. And the next one's more important. It's a thread that's actually going to be torquing down to compress the spring. So I would love to just take this rod and flip it around and thread the other side, but you really need the nut in hand in order to decide when you're done with your threads, as you saw with this one. What all this is getting at is the next thing I need to do is work on this nut, because this is the one that's going to be threading on to the far side of that. Look at how not round this thing is. So I'm pointing right at this radius here. The flat is here. And it's following that radius pretty well. But when you cross the flat, suddenly like I'm a quarter inch, like 6 millimeters further out, and it follows. So it's like there's two different radii on this thing. Why? I have no idea. The flats are down, so it's not like it's top and bottom. That would be left and right as it's installed. Just like we did the last one, we need to drill it and then bore it to 1.915. So that just went through where the threads were. 1.8. Let's do 50 more. It's cutting out those old threads and it's not liking it. In fact, I may have just chipped my carbide. Yeah, I think that cutter is done. I hope I'm not immediately going to destroy this side too, but I don't really have much choice. It cut fine. I did a few more light passes to get to the exact dimension that I need. I don't know if you can see that. It actually came out to 1.916, which is good. I don't want to be small. 1/1000th big is fine. So I'm all ready to thread, right? Bit of a problem. Whenever you're threading, you want to cut on the leading edge toward the direction that you're threading. And I'll show this to you on a piece of paper in just a second. What that means is I want to have my compound arranged this way, the same way I did the other one. But the problem is with this big plate here, I am hitting the cross slide. So I can't get any closer than that. Like even if the cross slide wasn't there, I'm about to hit the compound. So the compound and the cross slide are both in the way of this big plate here. I didn't have this problem before because I was threading a much smaller diameter part and the cross slide and the compound didn't interfere with it. So it's confusing at first when you're looking at single point threading. Why are we doing this angle here and not just feeding straight in with the cross slide? The answer is because you get too much tool pressure if you try to plunge cut your thread. That's what you're doing when you just feed in with the cross slide. So you use the compound and you feed basically one edge of the cutter into the thread in small increments. So here's what I'm talking about. This is a close-up of the cutting edge, this is the boring bar, and it's sitting on this compound. And this is how I would like it to be arranged, because I'm threading in this direction. And if I now feed this in a small amount, I'm moving the cutter in that direction. So I move the cutter into the work like that. So the majority of the cutting, there might be a tiny bit that cuts on this left edge here, but the majority of it is on the right. If I were to feed straight in, you'd get away with it at first because you're only cutting a small amount. But once you get to the point where you're cutting a large amount, you're going to chatter like crazy, break your tool. You just have too much cutting pressure there. So doing the angle reduces the amount that you're cutting with each pass and reduces the area that you're trying to cut. Because when I engage, the slide is going to be moving to the right. I'm driving into my cut as I go, so I'm cutting on the leading edge. Here, I advance into the work this way, so this is the chip that I would be trying to take out, and it would get progressively bigger the deeper I get into the thread. But I'm going that way, so I'm cutting on the trailing edge. And you're not supposed to do that. I'm not sure how that's going to work. I've never done it before, but I'm thinking that might be what I end up doing here. My only alternative is to thread towards the chuck, which I really don't want to do. I think the high-speed steel is going to have a lot more luck if I can have a higher RPM. So if I thread at 220 or 360 RPM, it's going to make a better cut and a better job than if I have to slow down to 70 and grind my way through it. It's going to make a very dirty thread if I do that. And this thread's important. I'm going to be torquing this thread in order to compress the spring. I need these threads to work. I don't know. I guess I'll try this, this trailing edge thing. Yeah, now I can reach all the way to the back of the cut and come all the way out. No issues with the cross slide or compound. I have a better threading tool on order. But it's actually Christmas Eve right now, and I'm going to end up waiting a long time for that to arrive, thanks to the holidays, and I don't want to wait that long. Just touched. So now come out. Advance all the way to the back of the cut. And now you can go back in. Back to zero. That's correct. Out with the cross slide, in with the carriage, in with the cross slide. And now we advance our cut. I'll do 10. This first cut, you're barely doing anything, so it's the easiest one to do.
Seems to be working. Guess I'll just keep rolling with it and see how we do.
Pretty good looking thread. It did better than I thought it was going to do cutting on the back like that. They're definitely more formed than they were on the nut. These still have kind of flats on them, whereas these are pretty much to points. There's a little bit of flat there, I think, but not much. So now I need to make 7 inches of thread on this other end that actually will be screwed into there. Get this thing running as true as I can get it. I am going to thread to this point right here. So I need to machine a groove to exit the thread at this point. There, nice looking radius now. I'll slow down. Let's go to 70 and see what it does. So I found I could do a few passes at the higher RPM and then it would start chattering. I'd slow it down and do a few cuts that way, and I could go back and forth, and it actually cut pretty well. It's trying, but it's not there yet. So it took quite a while of cutting and testing, cutting more, testing again, but I eventually got here. Well, they're not the prettiest threads in the world, but they're going to work. So they're the prettiest threads in the world. So it's kind of funny, those threads were in there the whole time. All you had to do was remove this. I don't know why, but this nut having this old paint on it is bugging me, so belt grinder. Alright, now I got another problem. This hex stock that I made the nut out of was 2 5/8, and the largest socket I have is 2 1/2. So that will not go on there. Now I could shave this down on the mill or even on the belt grinder and make it fit, but I'm already getting a little thin and I don't want to do that. I need to put a lot of torque on this thing. In fact, this is smaller than the bolt head that was on the other bolt. See, so I really don't want to go smaller, and the only other sockets I have are too big, like this 3 1/2er. I went and looked at what a 2 5/8 socket would cost, and it's like 50 bucks for something I'll probably never use again. Let me see if I can just make something. That worked about as well as I could have hoped. This is clearly way too light. There's no way I'm going to be able to put the 1,000 foot-pounds I need to on this nut with that. This maybe could. This has 1/4-inch walls, but of course it was too big to begin with. But now that I have this there, this won't go on. Let's go beat on it a little bit. Alright, that really didn't take long at all, and I've got them fitting pretty well. A few taps and that would tighten up in there, but I don't want the nut to get trapped. So I need to shim at least 3 sides of this to push it and give me a little bit of clearance. This is some 12,000 shim stock, and I'm just going to try to put it in on 3 sides. If I weld that up and it tightens up now, I can press the nut back out, and then I should have clearance without the shims. Clearance, clearance. It's all about the clearance. So now all I need is a way to put a socket on the back of this. A couple different ways I could do that, but I think the easiest is going to be to weld on a nut that I do have the size for. It drops right into there and then it gets a little bit snug, but yeah, you can just push it right in. The question is this going to be able to take the torque I need to be able to put on it? I guess I could do something else on the outside, but I think that's probably going to work. I'm going to use it. If it seems like I'm starting to tweak this thing, I will reinforce it further. You know, this hammering a pipe on is a good option if you don't need tons of torque. In retrospect, I think it might have been a better option for me to just trace the nut out on a piece of plate, cut that out, maybe like a piece of 1/2-inch plate, maybe cut out 2 of them. So now I've got 1 inch of the socket and the nut fits in there, and then just weld that to a bigger piece of pipe. I think that would have made a more bomb-proof socket. But this really didn't take me that long. I think it'll do the job. Alright, now one thing I was planning on doing is making a washer for this because my new bolt head is significantly smaller than the old one. So I was going to make a big fat washer to help accommodate for that. The bolt head is going to be going down inside this right there. I noticed just now that there's actually an angle right there. See that spot right there is at an angle. It's not parallel with this, but it steps down. And if you look at the bolt that was in there, it also has an angle right there. So I reached down in there with my little angle gauge and was able to determine it is a 17.5 degree angle. Since I'm making a washer anyway, I'm going to make one side square to go against the nut, and I'm going to make the other side have that 17.5 degree angle so that it fits right against that. I actually got a bell center for jobs like this. And you might have noticed that I drilled enough to make a second washer. So I'm going to do that real quick. We'll see you back in a minute. Alright, I now have my 2 washers. I put the angle down. That now makes a flat, and that's what the bolt head will be against. So I'm actually going to tighten this down with an impact using my new socket. So now I'm just going to put a healthy weld in there, and that is going to keep that from ever unscrewing. The weld is not really what's holding the tension though, it's the threads. Alright, I'm trying to figure out how to screw this thing together safely. I don't want to just trust that nothing's going to break. I don't think it will. But if this spring gets partway compressed and then the threads give out, the nut, whatever, something breaks, and that spring forcefully goes back to its resting position and hits me, it's going to break me. So I'm trying to avoid that. Here's the deal. I need to put a lot of torque on this thing, and this is the nut. I have 2 flats here. So if I can hold that down forcefully, then I can prevent that from turning. I'm going to be over here turning the bolt inside there. So if I've got that side held down forcefully and something were to break, everything's going to launch this way. No bueno. I think I have a plan that will work here. So I cleaned the threads and put motor oil on them. There's other things that can help reduce the friction even more, but it seems most people recommended oil, and I went to the auto parts store. I couldn't find any molybdenum disulfide or some of the other stuff. Threaded right in. Now, can I put this thing back down without getting a hernia? You can see I'm about halfway through that plate because there's about 1 inch remaining there, and the threads start at 2 inches, so that's good. And before I forget, we're starting at 40.5. And 36 3/8 would be the ultimate target. The reality is I need to compress it a couple inches at least, because that gets me past what it compressed to tension the track. So that would again make this an immovable object to the track adjuster. So if I get to 38.5, that will be good enough. Let's see how hard it is, how much torque it's taking to get it torqued down. The other thing I want to do before I forget is reach in there and get some more oil on those threads. I didn't want to put it in all oily and get dirt all over it, so. I'm actually not sure if I hit record for that or not, but you get the idea. I put the bucket down on the flats there, and I supported the other side of the bucket because it wanted to tilt, and that made it knock off. So it's got a lot of pressure on it now. That should hold that, I would think. So now we can put our giant socket on. This is the thumb from the mini excavator, which I have positioned here to act as a safety cage.
So I kind of don't want to use an impact because I think that's more likely to mess up those threads. Last thing I need here is thread galling.
I used an online calculator. It said I needed about 1,100 foot-pounds to get to the maximum compression that I need. But I'm getting a little worried here because things get hard pretty quickly. So I should be more than an inch now. Yeah, I'm less than 39 1/4. I started at 40 1/2, a little more than an inch, about 30 millimeters. 1.5 inches is where it was tensioned to. So once I get past that, I kind of consider it all gravy. What I'm really after here is the fact that once the track is tensioned and I lower it back to the ground, it's not going to have tension on it from this spring. But I don't need to go to the gym today. Yeah, it didn't break, just came out. Just to show how many foot-pounds we're dealing with here. All right, I am at 39, and that is right where it was when it was tensioned. So I just need to get a little bit further. I don't know if I'm getting all the way to that 4 inches. I decided to reposition the excavator so I had a little more room to work here. And I changed over to my breaker bar. Place your bets. What's going to break first? This is definitely harder than I thought it was going to be. I ruined my breaker bar. Bummer. So I'm sitting here scratching my head on what I want to do. Thinking about my pin press, but it's not long enough for this. The rods on it are 36 inches long. This is measuring 39, and I have to have room for the jack, which is about 1 foot long. So I really only have like 24 inches on that pin press to work with. It's nowhere near big enough for this. You know, technically that did compress enough to tension the track, and I probably could just cut the end of that off, key it in place so that it can't unscrew, and call it good enough. But I'm just not happy with that. I've come this far. Well guys, that was a bit of a fail, wasn't it? You might even say an epic fail, at least at this point. But I'm not quite done. I have an idea. I think it'll work. I don't know. I think I'm going to try it, but at this point, this video's gotten long enough, and I'd like to see what your guys' comments are. What would you do with something like this?
Now, an obvious answer would be to go to a professional shop that has a big press, get them to press it, tighten the bolt the rest of the way down, and be done with it. I don't think I have any shop around here that's going to do that, and trying to get all that lined up, what they're going to charge me for it, all that's something I'd like to avoid if I can, and I think I have a solution that's going to work, but I guess we're going to have to wait for next video to see what happens. I don't like leaving you guys on a cliffhanger, but boy, it's been a lot of work to get to this point, and it's going to take me a while to get this solution together, so I wanted to get a video out for you guys. So thanks for watching. We'll see you on the next one.